What else? Problem number 38, they ask us, or they tell us, and then they'll ask us something. They say that you are told that the gravitational potential energy of a 2 kilogram object is 10 joules. So our potential energy due to gravity, and let's write this out. Remember, to calculate the potential energy of something due to gravity is m, the mass of the object, times g, which is the acceleration due to gravity, times the height. How far above a certain point, an arbitrary point, are you? And then they tell us that this whole thing is equal to 10 joules, and then they also say that the mass of the object is equal to 0.2 kilograms. 0.20 to be a little more precise. And then,
I thought it was 2.0.
oh no, it was 2. I'm sorry, I looked at the wrong problem. So it was 10 joules, but it was 2.0 kilograms. Now I'm going to do a real quick check. We want to do dimensional analysis whenever we talk about energy or work. What is the unit for energy or work? Joules. So they gave it to us in joules. That's good. And then for mass, what is the unit for mass? Kilograms. They give us kilograms. So we don't have to do any conversions. Always check for conversions, because sometimes they'll give it to you in grams. Sometimes they'll give you in something other than joules, and we need to make those conversions. Okay? All right. So now they have A, B, C. Oh, no, they have an A and a B part. So A, it says, with this information, what can you determine? And here are the options. Can you determine its initial height? So can we find the initial h? B, it says, can we determine its final height, which is just h? Right, so I probably should clarify this. Initial h dot, h sub 0, is always going to refer to as the initial height, or initial whatever. So whenever we see this subscript notation, the 0, which is pronounced not, right, which is like 0 is nothing, not is nothing. So h naught is the initial height, and then the final height is just h with no subscript notation. Sometimes you'll see somebody like me or Father Jim will say I and F for initial and final. I'm going to try to stick to the book as best I can this year. This is the notation they use. It both means the same thing, it's just written differently. So then for part A, this is still part A. So this is like A option number 1, A option number 2. Can we find these things? Part A, option number 3. Can we determine both the initial and the final height? And then there's a part B. What can you say has physically happened? Oh wait, there's a part 4, only the difference between the heights. So the other one is, can we find one or the other or both or delta H, the difference between the two. So delta H would be the final height minus the initial height. Okay? Can we find those? And then part B is just saying describe what has physically happened. So it says you are told that a gravitational potential energy of an object has decreased by 10 joules. Oh, wow. So we got to write this a little different. It has decreased by 10 joules. So what does that mean? That means that there's a change in the height, delta H, such that my final answer is negative 10. So what this means is there's an object that has a mass of 2 kilograms, and it has H naught. Now we could assume that it's in free fall because that's what potential energy means. So gravity pulls on this thing, and some of that potential energy gets converted into kinetic energy, and then at some point in time, it's at a different height. So think of this as like, this is a position in space, this is another position in space, and it moves a certain height. And it decreased. Now the negative 10 means that it decreased in potential energy because now the kinetic energy is equal to 10. That transfer of energy, remember, energy can't be created nor destroyed, just transferred. So the potential energy, like a roller coaster, when you're on the top of the hill, before you go down the hill, you're not moving. But over time, as you fall down the hill, that potential energy gets converted to kinetic energy, but it's not lost, it's just transferred. So as this object is standing here, it has potential energy. As soon as I let go of the object, it falls. Sometime later, it reaches a height h, such that it loses 10 joules of potential energy. All right? So can we determine the initial height? Like, can we say it's 100 meters off the ground? Can we say it's 200 meters off the ground?
Yeah, I'm confused on what do you mean by it decreases by 10 joules?
It's potential energy.
But if it's
So the question is, what do you mean by it decreases by 10 joules? Okay, so we don't know what the initial energy is. In fact, I probably, to be a little more accurate, I should say that there's a change in potential energy. So let's just pick a number.
20.
Originally, it had 20 joules of potential energy. I let go of the object, it falls, I measure it a little bit of time later at a different height, and now if I were to calculate the potential energy based on this formula, it would be 10 joules less.
It's used up energy.
So the change in the potential energy is 10 joules less. Okay? So the question that they're asking us is, based on the information that they've given us, can we determine the initial height? Can I say the initial height was 100 meters? Can I say it was 200 meters? Can I say it was 300 meters? Could I determine the final height? Maybe, maybe not. I don't know. That's what they're asking us. That's what we're trying to figure out. Can I determine the difference in height? Delta H. Could I determine the initial and the final height? That's what they want us to know. Well, if you look at the formula there, what do you notice? I kind of gave it away by putting the formulas up there.
It gives you mass, gravity, and then you just need to know, you just solve for the height.
But in this case,
What's the difference?
it's delta H.
Oh,
So what could we find?
Just delta
Between the
H.
initial and final.
Yeah, so the answer is we can only really find delta H, right? This is all we can really find.
Oh,
Okay? So let me draw a picture just to kind of help you guys out. So if I have this object here, 2 kilograms, and we'll do the answer in a second. And this is, think of this as a very tall building. This height right here is h naught. Now, I could calculate the original potential energy as the mass times the acceleration due to gravity times h naught. That will be some number. I don't know what that number is. I could take the final velocity, or the final potential energy, which is mg, the final position. But based on the information they've given me, I don't know what that is. So, in other words, we let go of this object, we wait a little bit of time, gravity pulls it down, there's a change in position. What I really want to know is it says that the change in potential energy is decreased by 10 joules. Well, the change in potential energy is just the final potential energy minus the initial potential energy. Okay? So if I write this out, then delta U is equal to, what was this? mg h minus mg h naught. Right?
yeah.
Does that make sense? What do both terms have?
Energy.
mg. So now if I factor out mg, I get m times g, and then that leaves me h minus h naught, which is delta h. So the change in potential energy is mg delta h. Sometimes your textbook will write it like this because it's in the y coordinate system. They'll say mg delta y.
Gotcha. Yeah.
Does that make sense? Okay. So now, what did they tell us? They told us in the problem that delta U is negative 10, that the mass of the object was 2 kilograms, and that G, we should know by now, is 9.8 meters per second squared, and this is in joules. Check all the units. Energy is in joules, mass is in kilograms, acceleration is meters per second squared. And so the question conceptually is we can really only figure out the change in position. Okay? Well, how do I figure that out? Well, algebraically, if I take this equation and rearrange it, I get that delta y is equal to delta u all over the mass times the acceleration due to gravity, which is 10 joules, all over the mass, which is 2 kilograms, times the acceleration due to gravity, 9.8 meters per second squared. And I guess if we wanted to be real formal, I almost forgot the negative sign because there's a loss there. So now delta y then, if I crank through all this on my handy dandy calculator, I get is about 0.51 meters. And what does the negative 0.51 represent?
It's decreased.
It's gone down, right? So if I come all the way up here, from this point here, I gotta go all the way to the top. From here to here is 0.51 meters. It's negative because I'm going in the negative direction, and this is positive.